Hello and welcome to the second part of my Tackle Math video, all about quadratic equations. My name's Chris. Okay, so the video I posted yesterday showed you how to solve quadratic equations using factorization very quickly. We had a quick look at the formula, didn't really apply it, and then most of the video I was talking about the complete the square method, and then I showed how the technique behind complete the square can actually be used to show something about the equation, the curve of the equation. Now we can actually sketch it using having first completed the square. Right, in today's video I'm going to do a little addition to completing the square, and then I'm going to apply it to the general function of a quadratic, general form of a quadratic, which is what we've got on the screen there, and see what we come up with. Now, just a little bit of catching up on yesterday. The version, I only gave one example yesterday of completing the square, and I gave an example where the coefficient of the x squared, coefficient is just a number in front of each component, was 1. And actually you kind of need it to be 1 to complete the square. Might be possible without, I wouldn't want to try it. Much easier to divide throughout first by the coefficient of x squared, like I have there. So that's 2x squared plus 4x plus 7. You can divide throughout by 2, and you get x squared plus 2x plus 7 over 2, and then we can apply complete the square on that. I'm not going to do that now. I did that on the video yesterday. That's just a starting point, something that maybe I should have mentioned in the first video. Okay, so now let's try and apply completing the square to what I call the general form of the quadratic equation. So, first of all, do what we just did, divide throughout by the coefficient of x squared. So we have everything here divided by a. A divided by 1, that's why we're doing it. B divided by a, x plus c divided by a. And then 0 divided by a, which of course is 0. So we've got that, and now we're ready to start applying completing the square. Now this is where I'm going to choose a different colour, because this is like a side branch in our investigation. Completing the square involves taking half of the coefficient of x, the number before the x, and sticking it in a form like this. Now half of b divided by a is b divided by 2a. And so that's squared. And I say it's a side branch because we're now just going to multiply this out and see what we get. And we get x squared plus b over a x, because we've got two lots of b over 2a x, which is b over a x. And then square the last bit, which is b squared over 2a squared, which is actually 4a squared. We've got to square the 2 and square the a, 4a squared. So this is where we then compare what we got from this expansion with what we've got here. So this is where I'm going to change back to green and carry on solving the equation. So what we've got here is two things we're going to compare. And this bit expanded equals all of that. So if we're going to rewrite this whole thing here, down here, as x plus b over 2a squared, that covers that bit, but it also gives this extra bit. So we've actually got to take that bit off, because that doesn't appear here. So I should have said at the beginning of this really is aimed at students who are aiming for a 7, 8 or 9 rather than a 4, 5 or 6. You probably wouldn't have to do this. It's just a bit of a background interest for students who are aiming high. So take off that and then add that on. So c over a equals 0. Probably the most complicated step of that whole process. I'm including that. When we expand that, it's got that bit which isn't in there, so we've got to take it off, and then we've got to add that bit on. Okay, So this bit here, there, is actually the same as x squared plus b over ax. Okay, so now we're just going to rearrange this slightly by x plus b over 2a squared equals, what I'm going to do now is I'm going to move these two terms to the other side. I'm going to add that to both sides. You get b squared over 4a squared. And then we're going to take this from both sides. So it disappears from that side. And on this side, it appears as c over a. Okay, so all I've done there is rearrange it, move the terms that aren't part of this square onto the other side. Okay, so move it up a little bit, give myself a bit of space. Let's leave this side alone just for the time being. I'm just going to make this side all into one big equation. Now, we're looking on one big equation, one big fraction. So 4a squared goes on the bottom, because that is actually the denominator we can have, the common denominator we can have at the bottom. And the bottom, the b squared bit we haven't changed. That's still b squared over 4ac. But to make this next bit over 4ac, we've got to multiply it by 4a. If you cancel the 4a out now, there you end up with the c over a again. I've just done with algebra what you're probably quite used to doing with fractions when you're adding and subtracting them. Okay, so now what we have to do is take the square root of both sides, because the square root of x plus b over 2a equals the square root of b squared minus 4ac, and that can be plus or minus. A square root, when you start taking square roots, you can't forget the minus version of the square root, and the square root at the bottom of the whole thing, there's plus minus of the whole thing, but we're putting on the top. And the square root of 4a squared is actually 2a, plus or minus 2a, but the plus and minus kind of interacts at the top. We only have to put it on the top. Okay, so now what we're going to do is move up a little bit more. And now we're just going to move that bit to the other side, that b over 2a to the other side. And that becomes minus b over 2a. We've actually got 2a on both sides now. Actually, that is that. We don't need to do any messing around with the denominator here, because actually you've got the same denominator, which is 2a. And for what I'm going to do is I'm just going to, could have moved it, I'm rewriting it. Move it a bit further over. Plus or minus the square root of b squared minus 4ac. And that's what x equals. And that is the formula, which we had a brief look at yesterday. So basically what I've shown here is by completing the square and by fiddling around with the algebra, I can find the formula for the quadratic equation, which is, I think, quite neat and clever, which is why I'm making a video about it. Just move that picture, because I just want to go back to one of my earlier screens. That is the formula. X equals minus b plus or minus the square root of b squared minus 4ac. Now, the other bit, I don't really spend much time applying the formula here, but it's interesting actually that you can now use this to work out when you're going to get one or two or no solutions to a quadratic equation, because there's the possibilities. Let me just draw a graph to represent this. I'm going to go to black to do this. Doesn't work very well with the pen. Let's do that. So we're now going to draw a graph. And this is where, again, I can only apologise that I'm not very good at drawing parabolas on my whiteboard. Much easier this is on paper. Ooh, hang on. See what's even harder. Don't turn the line function off. That's roughly a parabola. It's not a very good parabola at all. But any point on the y graph where you're sort of going to choose the solutions. So, for example, let me draw a red line on here, which is going to be hopefully movable. If the value of you're trying to set the equation to is up here, that line crosses in two places. Yeah, there and there. If the value is there, you end up with one answer to the equation. If you put it down there, you don't get any values at all because the line doesn't cross the parabola. Now, that's all very well, but what does that leave us with this equation, with this formula? Well, the plus and minus bit here is the bit that sort of generates two solutions, because you have a solution with plus and you have a solution with minus. Now, square roots, there's two square roots from those numbers, from those positive numbers. If it was 0, let me just put it right again. 0, the only square root of 0 is 0. The square root of any positive x is plus or minus square root of x. That's when x is greater than 0. But if x is less than 0, you can't find any square roots. There's no numbers you can think about if you multiply x, well, let's say a by a equals -5. To actually get what a is there, you have to go into an area of maths called imaginary numbers, complex numbers, which is above what you need to learn for GCSE maths. I don't know. Pretend I almost didn't say that. We're only dealing with the numbers you know, what we call real numbers in GCSE maths. So this doesn't have a value then, if that is negative. Now, one of my students, he said that they give this name at school now, which I don't remember from school. But this thing called b squared minus 4a, see, something called the determinant, or he's got a name for it, it's not a determinant. I have to ask him and write it below this video. I'm seeing this afternoon. So, b squared, if b squared minus 4ac equals 0, then you've only got one solution. If b squared minus 4ac is greater than 0, you've got two solutions. If b squared, let's move things up a little bit. If b squared is less than, or minus 4ac is less than 0, then you've got no solutions, no real solutions. Or you can actually write them differently. You can write it as if b squared equals 4ac, then you've got no solutions. You've got one solution. You've got one solution. If b squared is greater than 4ac, then you've got two solutions. If b squared is less than 4ac, then you've got no solutions. So, if I were to write the equation now, nearly the end of the video now, stay with me just a few more moments. If you get b squared, so you get the equation x squared plus, let's stick with 4x plus. Now, if you make, then that's 4. So if you make 4 the number on the end here, then what you've got is b is 4, that's 16. and 4 times 1 times 4 is 16. They're together. So this is actually the equation x plus 2 squared. And that only has the solution x equals minus 2. There's only one solution. If you were to make this number 5, then the 4ac bit becomes 20. And 20 is greater than 16, 16 is less than 20. So then, this one here, there are no solutions, no real solutions, I should say, there to be complete. But if that number there is 3, then this number here is 12. That sign becomes there, and we do have solutions. So basically, you can actually work out by looking at b squared and looking at 4 times a times c, where b squared is the coefficient in the middle of x, a and c are the coefficients of x squared. Now, you can find out if there's going to be a solution before you do any work. And then, if you find out there's no solution, you don't even have to bother with the formula or the completing the square or anything, or trying to factorize it, because you can just say no real solutions, unless you want to start working with complex numbers, which I don't recommend at this point. Okay, so thank you very much for watching my second video, all about quadratic equations. And actually, I said I'll be seeing this student this afternoon. I actually saw him yesterday afternoon by the time you see this. So I'll write below, I'll remember to ask him this afternoon what he calls that thing. Because I should know and he knows, so I'll ask him. Okay, so thank you very much for watching this video, and this video will be going up tomorrow. So I made this video yesterday. Oh.